Hello and welcome to Principles of Mathematics lesson number 23. In this lesson, we're going to learn about percents. We'll also learn that fractions, decimals, and percents are all representations of rational numbers which can be converted into one another, and we're going to look at some of those conversions. We're going to learn about proportional relationships to solve percent problems, mainly in the sense that we will represent an equation called the percent equation and learn how to use it. We're going to look at techniques to solve problems including discounts, interest, compound interest, and percent increase and percent decrease. Strategies for percent mental computation and estimation will also be covered. Let's go ahead and dive in. Percents are special kinds of fractions, namely fractions with a denominator of 100. The word percent comes from the Latin phrase percentum, which literally means per 100. So the definition of percent for a given number n, for example, n percent, that simply means n divided by 100. To convert any number to a percent, the most universal method would be simply to take that number and multiply it by 100%. Now, that works because if you take any number and multiply it by 100%, what are you really doing? Remember, 100% just means 100 over 100, which is what? 1. So this is n times 1, which is n. So by doing so, we're not changing the number, but we're just going to change the way it looks. Of course, we're not going to remove the decimal like we did here. Here was just a demonstration of why it doesn't change the number. Normally, we'll just multiply the n by 100 and leave the percent to get the problem into percent form. So for example, for 0.03, all we have to do is take 0.03 and multiply it by 100%. Now we go ahead and take care of 0.03 times 100, which of course we know is just multiplying by 100 just moves the decimal 2 places to the right. So this becomes 3, and we keep the percent because we want to write this number as a percent. So the multiplication was just for this part. Okay? Now, you should go ahead and try all these on your own before you watch me do them, because you should know what needs to be done at this point. But assuming you've done that, we'll continue. So 1.2, we're just going to take 1.2 and we're going to multiply it by 100%. Again, since we want to keep the percent to represent the number as a percent, we're just going to multiply this part out, right? 1.2 times 100, of course, is simply 120, because we just have to take the decimal here, move it 2 places to the right. So I have 1.2. When I move 2 to the right, I run out of digits. I need another one. So the decimal is now there. So we get 120%. Let's see if that makes sense. Remember, we know that 100% is 1, right? So anytime you're dealing with a number larger than 1, you should expect a percentage larger than 100%. That's just common sense, right? And of course, if you're working with a number between 0 and 1, strictly less than 1, you're going to expect a percent less than 100%. Again, common sense. 1, of course, itself, we can convert into a percent by doing the same thing. Just multiply by 100%. This part is 100, so we just obviously get 100%. So 100% of whatever you're looking at, whatever number, is just one of itself or all of itself, right? All right, so for fractions, you don't need to treat them any differently. We're just going to take 2/3 and multiply it by 100%. Our assumption at this point in the class is you do know how to do basic operations, so we're going to go ahead and utilize a calculator. All right, so we're going to enter 2/3. I'm going to go ahead and use a parentheses to keep it nicely together like this. And then we're going to exit the parentheses by hitting the right arrow, or you can hit the right arrow on your computer. If you're working on a computer, this calculator works nicely with keyboards on a computer. And then we're going to multiply by 100, right? Remember, we don't want to multiply the percent out, we're just multiplying this part out so that we can keep the percent symbol, right? So we're just multiplying by 100. All right, and we get this. Now, notice that one way we can give the answer, of course we know this is a repeating decimal. That 7 is actually a 6, it's just being rounded because of the limitations of the screen, right? So one way we can answer it is we can say 66.6 bar. Remember, we use a bar above the repeatant, and here the 6 is the repeatant. So we can write it like that. Or if we want to work with fractions, for instance, or mixed numbers, we can hit the A, B over C button. It gives us that. We can do better than that. We can hit it again, and it'll give us the mixed number version. So we can say this is the same as 66 and 2/3%. Okay? Now, that makes sense once again. Remember, always think about whether your answers are reasonable or not. 2/3 is, of course, less than 1. Well, between 0 and 1. So we expect it to be a percentage less than 100%. Okay. How about this one? 0.3 bar percent, right? So remember what 0.3 bar is, right? Let's write it out a little bit. So it's 0.3333 forever, right? So we're going to multiply that by 100%. So let me get rid of the calculator for a minute. So notice that that's just going to move the decimal place 2 places to the right. So we're going to end up, of course, when I'm just multiplying this part, the 0.3333 on and on by 100, right? I'm going to keep the percent because I want to represent the number as a percent, right? So I get 33.333 forever percent, which I can write more compactly as 33.3 bar percent, like so. Now, if you recall that 0.3 bar is none other than, let me show you, 1/3, right? So you can also write it as 33 1/3%, like so. All right, so here we have a terminating decimal. That should be very simple. To get it in the form of a percent, we're just going to multiply by 100%. Again, remember, the reason we can do that is because 100% is 1. So we just go ahead and multiply it by 100%. And when we take care of this product here, notice multiplying by 100 is just going to move the decimal 2 places to the right. So we're going to end up with 0.042%. All right, for this next one, same business. We're going to do it exactly the same way. So we're going to take 3/5 and multiply it by 100%. So we can go ahead and take care of this product right here. So we're going to notice that we can cross cancel the 5 and 100. That leaves us 20 on the top. So we end up with 3 times 20, which is 60%. All right. And the last one, same thing. So notice that in order for me to put that into a calculator when I multiply by 100%, it's easier if I turn that into an improper fraction. So 7 times 2 is 14 plus 1 is 15. So I get 15 over 7 times 100%. And that's what we're going to perform on our calculator. All right, so we're going to put in 15 over 7. Remember, we like to use a parenthesis for that to keep it together there. Okay, so 15 over 7, and we're going to multiply by 100. So right arrow to get out of there. We're going to multiply by 100. We end up with this. It would be nice if we can give that into a format which is a mixed number. Or if we want to, we can round and give this number, or figure out, more of the digits, see where the repeatant is. But let's go ahead and turn it into a mixed number. So if I hit that, that's going to give me 15 over 100 over 7. But if I hit it again, it'll give me 214 and 2/7. So this is 214 and 2/7%, like so. All right, so that's basically how you do conversions when it comes to going from decimal notation to percent. A very universal method I've shown you. It works, notice, with all kinds of numbers. So it doesn't get much better than that. All right, let's move on. Now, to go the other way is easy as well, because what you're going to do, basically replace the percent by either dividing by 100 or multiplying by 1 over 100. The same thing. Remember, dividing by 100 is the same as multiplying by 1 over 100. So I can take 5% and that's 5 over 100, and then go ahead and work it out and see what I get. Or I can say 5% is 5 times 1 over 100. So the recommendation is, if you're just dealing with a whole number like this, just go ahead and write it as 5 over 100. But if you're dealing with a fraction, it's easier to think of it as times 1 over 100. So that way you don't get a fraction over a fraction. So it'll be easier if you think of it that way. So replace your percent with that. When you're trying to work with fractions, replace it with over 100 when you're working with whole numbers. All right, so 5% is just 5 over 100. So if I wanted to represent the answer as a decimal, I'll do it right away. I know I just have to move the decimal 2 places to the left on 5, so I get 0.05, right? But if I wanted to write it as a fraction, I would just reduce that to 1 over 20. Okay, how about the next one, 6.3%. So we know that that's just going to be 6.3 over 100. Now move the decimal 2 to the left on 6.3, you end up with 0.063. So that is what 6.3% is in standard decimal notation. All right, 100%, we already know what it is, but let's see if this method works with it. Of course it does, because we're just going to write 100 over 100, which is 1, okay? For 2/3%, as I recommended here, instead of dividing by 100, do the equivalent operation of multiplying by 1 over 100. So you get 2/3 times 1 over 100. Or simply, if we simplify a bit, we can see we get 1 and 50, right? When I cross cancel the 2 and 100. So basically I'm looking at 1 over 150. Okay, so 1 divided by 150. So I end up with a number that's clearly 6.6 bar. Remember, it's being rounded there. This is really just a repeating 6 times 10 to the negative 3. Remember, they're giving you the answer in scientific notation. So that means if I want to actually have a regular decimal, what I'm going to do is I'm going to move the decimal 3 places to the left. So here's 6. Let's just look at 6.6 for example. When you move the decimal two places to the left, you get 0.006. So we end up with 0.006. And remember, the other 6's are going to be there and they're going to repeat. So it's just going to be 0.006 bar. Of course, if you wanted the number as a fraction, then you would be finished right here. It's just 1 over 150. All right, I'm not necessarily going in order, but no problem here. So 250%, that's just going to be 250 over 100. And of course, we know dividing by 100 moves the decimal 2 to the left, so that's just 2.5. All right, does that make sense? Yes, it's a percentage higher than 100. So when I convert it, I should get a result that is higher than 1. So that makes sense. All right, 33 1/3%. So notice that's 3 times 33 is 99 plus 1 is 100. So that's 100 over 3. And the percent, as I did with 2/3, I'm going to replace by multiplying by 1 over 100, which is the exact same thing as dividing by 100. Now I notice, look, the hundreds cancel out. So I just basically get 1/3, okay? And if you want the answer in fractional form, you're done. If you want it in decimal form, then just divide 1 by 3. I think you know what that is by now, right? It's just 0.3 bar, right? But just in case you're curious, here it is. So we can either write it as 1/3 or we can say 0.3 bar. Now do notice that when you write 0.3 bar, that is an exact answer. That's not an approximation. So that is just as good of an answer as 1/3 as far as being exact. All right, so that's how you handle that direction of conversion from percent back to a decimal. All right, now we want to look at some applications involving percent. Applications involving percents usually fall into one of these categories: finding a percent of a number, finding what percent of one number is another number, and finding a number when a percent of that number is known. Let's take a look at these types of examples and see how they work out. Before we get to our actual examples, I want to tell you about an important equation or formula. There, it's called either, is namely the percent equation or formula. With pretty much any type of percent question that we get, we can handle it by using this particular proportion, and that is that part to whole is equal to percentage over 100. So a simpler way of writing that is this, which is the way we're going to use it, and it's in the form A over B equals P over 100. Here, the easiest ones to locate in whatever question you're being asked are the B and the P, because this B always comes after the word of, and the P always comes before the word percent or the symbol of percent. So if we keep that in mind, we can handle pretty much any kind of percent, simple percent problem they throw at us. Let's take a look. All right, so with each of these, I want to look at them in two different ways with you. And one is, before using the percent formula, I want to show you what actually my preferred method is, because there's absolutely no memorization, okay? With that method, you just translate directly from English to mathematics. So we have what number, so we can think of that as the unknown, right? We'll call that X. Is, we know in mathematics, translates into equals 20% of 50. So we have this simple equation: X is 20% of, which is times 50. So now we quickly convert the 20% to a decimal to make it easier to work with, or you can just write it as a fraction, for example, and deal with it that way too. So for example here, since that's such a nice number, I'm just going to go, that's 20 over 100 times 50, and we go ahead and simplify that since we can. All right, we notice that, for instance, we can cross cancel the 50 and the 100. That leaves us 2 on the bottom. So now we're almost done because we get x equals 20 over 2, which is 10. All right. So now we know that 10 is 20% of 50. Let's see if we can handle it now also with the percent equation. Remember, we had A over B equals P over 100. Now we remember that this word always comes after of the word of, and this one always comes before. That's the lazy way of writing before percent, right? So if we go back to the original problem and look, what comes after the word of? 50. So I know that's going to be my B. And what comes before the word percent? And that's 20, right? So the number you're looking for is going to be, the unknown is going to be the A, right? So we get A over B, which is 50, equals P, which is going to be 20 over 100. So in this way, we just get a simple proportion, which we can solve by cross multiplying. So one cross product is 100A. And the other cross product is 20 times 50. Now I recommend you don't multiply it out. Just go ahead and divide both sides by 100 as is, because then it'll be much easier to see the cross cancellations. Here the hundreds cancel out. On the other side, we know that 100 goes into 50, or rather the other way around. 50 goes into 100 twice and into itself once. So we get a 2 down below. So again, we get, of course, the same answer. So we get A equals 10, 20 over 2 or 10. All right, so whichever method that appeals to you, you can use. I like this first method just because there is no memorization. You don't have to remember what comes after this or before what, etc. So, which is what you need to do with the percent equation. It's very powerful, of course, and very efficient, but this one, just very natural. You just translate, right? So let's go ahead and look at this one down here. 60 is 20% of what number? We'll do it using direct translation first. So 60 equals, the is becomes equals 20%, which is like 20 over 100, right? Of what number? So times the what number will be our x, right? Now, I can notice that this can be written as 60 over 1 equals 20x over 100. Never miss an opportunity to write an equation as a proportion if possible, because we know how easy they are to handle. This cross product is 20x, and this cross product is 60 times 100. Again, you don't need to multiply that out. Just write 60 times 100. Now we go ahead and divide both sides by 20 to solve for x. And we notice that the left 20s cancel out. On the right, the 20 on the bottom goes into the 60 on the top 3 times. So now we have our answer. We get x equals 3 times 100 or 300. So what we just discovered is that 60 is 20% of 300. All right, we could do it using the percent equation. Let's do it. A over B equals P over 100. Once again, we look for B after the word of. We look for P before the word percent or the percent symbol. Okay, so in this way, we notice that what comes after of in this problem is the unknown. So that's going to be our B. And what comes before this percent symbol is 20, so that's going to be our P. So that leaves only one number, that must be our what? Our A, okay, which is the part to the whole. All right, so now we go 60 over B is equal to 20 over 100. Again, we will cross multiply, so we get 20b is equal to 60 times 100. Divide both sides by 20 again. And of course, same cross canceling as last time. So we get b equals 300. We of course expected the same result, okay? So two different methods, same result, of course. For the next one, we have 70 is what percent of 40? When we're going to translate that, notice that we end up with 70 is equals what percent? That translates as x over 100 times 40, right? Let's turn it into a proportion so we can quickly cross multiply. So 70 over 1 equals 40x over 100. So we get 40x by cross multiplying equals 70 times 100. So now we get x equals, we're just going to divide both sides by 40, right? So we get x equals 70 times 100 over 40. I could do some cross canceling here, but I can see this is not going to be as nice a number as some of the others, so I'll just go ahead and bring in my calculator now. So let's see, we have parentheses 70 times 100, and we go ahead and write it, get out of the parentheses there, and then divide by 40. And we end up with 175. All right, so it turned out to be a nice number after all. So we get 175. So basically what we're saying is that 70 is 175% of 40. Common sense check. Does it make sense? Well, yes, 70 is a larger number than 40, right? So it makes sense that 70 should be a percentage which is higher than 100 of 40. So it does pass the common sense check. Now, we can also do a quick check like this. Just take 175%, so divide by 100, and multiply that by 40, and we should get 70, which of course we do, okay? So just a nice quick check. Again, you can do this with the percent equation as well. So in this case, once again, we say A over B is equal to P over 100. For B, remember, we're looking for what comes after the word of. For P, we're looking for what comes before the word percent or the symbol percent, right? So we notice that what comes after the word of is 40. So that's our B. We look for our B and P first because those are easy to look for, right? And what comes before percent is the what, right? So that's going to be my P is just going to be the unknown, right? And the other one that's left must be the what? That must be A, okay? So now we say A, which is 70 over B, which is 40, equals P, which is unknown, over 100. Now we go ahead and cross multiply, so we get 40P equals 70 times 100. Divide both sides by 40, we get P equals 70 times 100 over 40, which we've already calculated to be 175. All right. So there's 3 examples we've done in both methods, right? So we're just going to do the next one using my favorite method, which is just use it by direct translation, right? So 200% of what number is a half? So 200 over 100, that's 200% of, which means times. What number becomes x, is becomes equals, and then we have a half, right? Now I'm going to go ahead and cross cancel here because it makes the numbers so much nicer, and it's so easy to do. If it was a pain to work with, I wouldn't have done it, but since this is so easy, I'll do that. So I get 2, right? So basically we have 2x over 1 equals 1 over 2. So we'll go ahead and cross multiply. We have a nice proportion, so we get 4x equals 1. So you get x equals 1/4. Of course, this can be done using the percent formula, and I'm going to do that for you. So make sure you do that before you move on to convince yourself that it works in that method as well. All right, so that's how you handle these basic percent problems. All right, so most of the percent problems that you encounter aren't going to be given in as obvious a format as the ones we looked at. Those are, of course, just for instructional purposes. So what the trick is to take these problems that are not as clearly stated and turn them into one of those simple questions, right? So a house that sells for $92,000 requires a 20% down payment. What is the amount of that down payment? So basically, we want to know what is 20% of 92,000. That's it. That's the question we're dealing with, right? So what is becomes x equals 20% is 20 over 100. Of in mathematics means times, and then 92,000. That's it. So just simplify that. Now I notice that 100 goes into itself once, into 92,920 times. So now all we need to do to find the value is multiply 20 by 920. All right, so let's do that. Okay, so 20 times 920. So 18,400 is the amount of down payment you would need. All right, so what is the amount of down payment? We can answer it using the proper symbols. We'll just say $18,400, like so. Okay. All right, so here we have Alberto, who has 45 correct answers on an 80-question test. We want to know what percent of his answers are correct. So basically, we want to know 45 is what percent of 80? So very simply, we say 45 is x over 100 times 80. And we realize that's just 45 over 1 equals 80x over 100. We go ahead and cross multiply. We get 80x equals 45 times 100. So we divide both sides by 80. We end up with x equals 45 times 100 over 80. So now we'll bring up our trusted friend. 45 times 100. We'll make sure to get out of the parentheses and then divided by 80. So $56.25. All right, so basically he got what percent of his answers are correct? 56.25% of his answers are correct. Now, with this particular kind of problem, right? One number is what percent of another number. There is a very quick shortcut. So all you have to do is divide 45 by 80. So it's, I mean, I couldn't not share the shortcut with you, right? All right, so 45 over 80. Now, however, notice that when you do that, you're going to get what decimal part of 45 is of 80. So since we want to give the answer in percent form, just go ahead and multiply that by 100%. And now your answer will be in the proper format as well. So you just go, basically it's the same computation, right? But I'm telling you that you can avoid all the equation or even the percent formula in this very simple scenario where you want to know A is what percent of B. One number is what percent of another number. So all you do is you figure out what decimal part of the second number is the first number by just dividing, and then you multiply by 100% to make it a percent result. Okay, so of course we're going to get 56.25% once again. Okay, so there's that. All right, so here we have another problem. 42% of the parents of the school children in Paxton School District are employed by the Paloma University. If the number of parents employed by the university is 168, how many parents are in the school district? Now notice that they're giving us two pieces of information about those parents, right? One is that they're 42% of the total number of parents in the district, and that they basically comprise 168. So basically we want to know, if we remember, we're going to translate into a much simpler question. We just want to know basically 42% of what number is 168. That's all we're trying to figure out. All right, so we basically have 42%. Now, normally I've been turning these into fractions, 42 over 100, then turning, applying the proportion scenario with cross multiplication. So I just want to show you, you could also do it like this. So you've seen it all. So 42%, that's basically 42 over 100, which is 0.42, right? So you could handle this in that manner. You could say 0.42n equals 168. and just divide both sides by 0.42, which is 42 hundredths, of course, if you want to read it correctly. So you say n equals, now we're just going to do the division, 168 divided by 0.42. So we get 400. So how many parents are in the school district? 400 parents, right? Like so. All right, so again, with all of these, do try them first before you watch me. And if you didn't get it right, once you learn how to do it correctly, then just start from scratch, see if you can do it then without any help. Keep doing that until you can do it with no help at all, okay? And that's when you've got it. Okay, here we have another scenario. Skis at a sports store near Humphrey Summit are on sale for $476. If the original price was $560, what percent were they discounted, right? Well, basically, we know the amount they were discounted, right? And we want to know what percentage that is of the original price, right? So let's find that amount real quickly. So the amount of the discount is very easy to calculate because that's just 560 minus 476, right? So 560 minus 476, so 84. So we know how much the amount. So basically we want to know this $84 is what percentage of the original price, which was 560. Now I am going to turn this into a proportion. 84 over 1 equals 560x over 100. Cross multiply, so we get 560x equals 100 times 84. Now all we have to do is divide both sides by 560. These cancel out, so we get x equals, now we're just going to compute. $100 times 84 divided by 560. So we get 15. So basically the markdown was 15% of the original price. Or you say the discount was 15%. So marked down 15%. Okay, that's that. All right, next we want to look at some mental math with percents. In order to do that, it's really good to be familiar with some of these common percents and their fractional equivalents, like 25%, that's 1/4. Of course, because 25 over 100 reduces to 1/4. Same with 50%, etc. We've seen all this. So these are really good to know because they help you do some mental math very quickly, like 33 1/3%, that's 1/3. 66 2/3%, that's 2/3. 10% is 1/10. 1% is 1/100. A couple of other useful ones, 20%, that's 20/100, so 1/5 if you reduce it, right? We have 5%, which is 5/100 or 1/20. So these are good to know when you want to do quick mental computations as well. So again, 20/100, right? That's 1/5 if you reduce them. And 5/100, that's of course 1/20 if you reduce it. Okay, so that's where they come from. All right, so let's say we want to calculate 50% of 62 using some of these fractions that we just saw as equivalents of percents. So I noticed that 55% of 62 I can think of as 50% of 62 added to 5% of 62. Now, I know that 50% is a half, so that's just a half of 62. Now, if this number here was actually a multiple of 20, I would have thought of 5%, as I told you on the previous screen, as 1 over 20. But it's not, so it'll be a little bit easier for me to think of 5% as a half of 10% of 62. Now, 1/2 of 62 is just 31. So that's 1/2 of 60. Now, notice I can use compatible fractions. I know a half times 62, that's easy, that's 31. And I know 10% is 1/10. So here I'm looking at 1/10 of 31, which is easy, of course, because that's 3.1. So I get 31 plus 3.1, which is 34.1. Now, you're thinking, whoa, that's a lot of steps. So how is that mental math? Well, the point is, notice we didn't use a calculator at all. We didn't need it because we were able to do it all with simple math here, arithmetic. Okay. All right. Estimations with percents can also be used to determine whether an answer is reasonable or not. Let's take a look at an example. All right, Laura wants to buy a blouse originally priced at $26.50, but now on sale at 40% off. She has $17 in her wallet and wonders if she has enough cash. How can she mentally find out? Well, we know that 40% of that number is not going to be an easy mental calculation, right? But what about 40% of $25? That would be quite easy to figure out, right? Think of 40% as 4 times 10%, right? Now we know 10% is 1/10, right? And 1/10 times 25 is just going to give us 2.5. So we get 4 times 2.5, which is what? 10, right? Now, so Laura estimates that the blouse will cost $26.50 minus 10, or around $16.50. Now, since the actual discount is actually greater than $10, what does that tell you? She should know that she's good to go, right? She has enough money, because the actual discount would have been from a larger amount, so it would be more. All right, so that's how we could help Laura there. All right, here we want to take a look at some statements and see if they're true or false by kind of just looking at them, right? See if they make sense. Leonardo got a 10% raise at the end of his first year on the job and a 10% raise after another year. His total was 20% of his original salary. Well, this is definitely not true. The only way you can add percentages like that is if you're adding, if they're percentages of the same number or the same quantity. Now, of course, since he got a raise at the end of the first year, that means the number that you're going to use for the 10% of the second year is not going to be the same as the first year, is it? So we're talking about the 10% of some number A and 10% of some number B, right? A different number. So does it make sense that we should just say, oh, this is just 20% of the original salary? No, the original salary would have been A, right? So a quick example also will make you realize why this is so untrue. Let's say that the original salary was $1,000. Pick a nice number to work with, right? So when you find 10% of that, that's 1/10, so that's 100, right? So notice this, the salary at the beginning of the second year was $1,100, right? So then you want to figure out what 10% of that is. which is $110. And of course, this amount is not just 20% of $1,000, right? Because this would be 220, and the 20% of 1,000 would have been 200. So here's a quick example to make you realize why this couldn't be true. So this one is false. Now, Young and Dina paid 45% of their first department store bill of $620 and 48% of the second department store bill of $380. They paid 45% plus 48% of which is 93% of the $1,000 bill. Again, we can't do that, right? Because we're not dealing with the same amount, right? That this was 45% of one number and this was 48% of another number. So we can't factor out and just add the percentages, right? Notice that if we had, for example, here, if we had 10% of a number and another 10% of the same number, then we could have factored out the A and say, okay, that's 10% plus 10%, so 20% of A. Same here in the second scenario, right? So the way you realize whether this is okay or not is whether you're dealing with just adding the percentages of the same quantity or different quantities. So here again, that would be false as well. All right, so on the next one, Bill spent 25% of his salary on food and 40%, now they don't say of what, they mean of his salary, right? On housing. So Bill spent 25% plus 40%, which is 65% of his salary. Yes, this is fine. Why? Because you're taking 25% of some number and adding it to 45% of the same number, which is the salary, right? So yes, you can factor out the n and say, okay, that's 25% plus 45%, which is 65% of n. You see? So that one works. How about here? In a town, 65% of the adult population works in a town, 25% of the same population works across the border, and 15% of the same population is unemployed. And everyone in town is exactly in one of those categories. Think about how you could quickly say whether that's true or not. Okay? I think you realize if that were to be true, then these percentages better add up to what? To 100%, right? But notice, what is 65% plus 25% plus 15%? That's 90 and 15, that's 105%. So that means what? Some of the people are working in more than one of those categories. So otherwise, this would have added up to what? To 100%. All right, so just common sense. So just to reiterate, the first one, C, was true, and this one was false. All right, how about this one? In Clean City, the fine for various polluting activities is a certain percentage of one's monthly income. The fine for smoking in public places is 40% of your personal income. For driving a polluting car is 50% of your personal income. And for littering is 30% of your personal income. Mr. Schmutz committed all three polluting crimes in one day and paid a fine of 120% of his monthly income. Do you think that's true or not? Well, first of all, yes, we can add those percentages because they're all percentages of the same thing, right? So let's just call it monthly income, or I, right? So 40% of I plus 50% of I plus 30% of I. Yes, you can indeed factor out the I and just add the percentages. And indeed, we end up with 120% of I. So yes, this is true. Mr. Schmutz was in deep trouble that month. Okay, that's that. Let's proceed. Next, we want to learn about simple interest. Suppose you borrow $6 from a bank at simple interest at a rate of 5% to be paid off 2 years from now. First, we want to learn what these names are going to be. This 6,000, the original amount, is called the principal, okay, or the amount of loan. Now, it's the loan if you're, of course, borrowing, and it's investment, for example, if you're putting it in a savings account. The 5% represents the interest rate, and the period of the loan is the amount of time that you owe the money. In this case, it would be for 2 years. Now, the simple interest means that interest will only be computed at the on the principal of the stated time of the loan, not any interest that may be accrued. That would become the category of compound interest. So the formula for simple interest is actually quite simple. The interest is going to be the original amount of the loan, the principal, times the interest rate times the time. And that's how you compute simple interest. Now, remember that this PRT is the interest. So if you want to know the total amount to pay off a loan, is going to be the original principal plus however much interest you paid, right? So it's going to be P plus PRT. If you factor out the P, you end up with P times 1 plus RT. So this is what we call the future amount, or the amount that you're going to owe in total. Now here's a situation where it's turned around and you're opening a savings account, so therefore you're the one who's going to be earning, right? So the savings account pays a simple interest at the rate of 5.25%. If she deposits $2,000 and makes no other deposit, find the interest and the final amount for 90 days. All right, so remember that for the interest, it's the simple formula PRT. Now, when we plug into this formula, we go ahead and put in the 2,000, the principal amount. For the rate, we usually like to take that and convert it into a decimal. So that's 5.25%, so that's 5.25%, right? And if you convert it to a decimal, that's 5.25 over 100, right? Which means move the decimal 2 to the left. So 0.0525 is what you would want to type in here, which is of course exactly the same as 5.25%. And the time here is not going to be like a whole number, because it's going to be just 90 days. So you just have to take that 90 days and divide it by 365. So you're going to be earning interest for part of the year, not the whole year. Now all we need to do is compute that. All right, so we have 2,000 times 0.0525 times, now I'm going to use parentheses, 90 over 365. And we get, now remember, we're dealing with money, so it doesn't make sense to go more than 2 decimal places. So approximately 25.89. All right, so if she were to take the money out at that time, how much money would she have? Well, remember, that's the future amount, which is the principal plus the interest, right? The amount that she deposited was 2,000, and she made 25.89. So if she were to take the money out at the end of 90 days, she would be walking away with 2,025.89. And of course, it's in dollars. We always put the units on the final answer. All right, so there's a simple interest problem there for you. All right, so next we want to find the annual interest rate if a principal of $10,000 increased to $10,900 at the end of 1 year. There are different ways you can go about doing this. You could just go to the formula that you know, the future amount is equal to the principal amount, the original amount, plus the interest, which we know is a PRT, right? Now, if we factor out the P, notice we just get 1 plus RT, right? So on the other side, you have A. So we know the future amount was 10,900 equals the principal, which was 10,000 times 1 plus RT. Now, T we know. We don't know the rate, but we know the T is just 1, right? So instead of T, we put 1 year, and we just get R times 1, which is R, right? So we don't need to put anything else. Now, notice if I quickly divide both sides by 10,000, right? I get equal to 1 plus R, right? So the rate is just going to be 10,900 over 10,000 minus 1. All right, and we go ahead and compute that. So we have 10,900. Let me actually use parentheses because otherwise it starts messing up later. So 10,900 divided by 10,000, and now we get out of the parentheses and we put minus 1, enter. So we get 0.09. So R is 0.09. Now we want to give the answer as a percentage, right? So we just go ahead and multiply it by 100%. Remember from early in the video? And we end up with 9%. All right. So this was really like the standard approach, right? Now, for those people who are just comfortable with this kind of thing and have worked a lot with money, the thinking would probably go more like this. Okay, let me just figure out how much the interest is, right? So this is another approach. You just go, okay, the interest is 10,900 minus 10,000, right? So it's how much? 900. So then all you got to do is use the I equals PRT formula, right? And you get 900 equals principal, which is 10,000, times rate, times 1, right? The year is 1, so we don't have to write anything else. R times 1 is 1. And then you get, of course, the same thing. And 900 over 10,000 is, remember, 2 of the zeros cancel 2 of the zeros, 9 over 100, which is once again 0.09, multiply by 100%, and you get that. So yes, this seems a little bit easier, but I wanted you to be able to carry on a little bit more of a complex scenario in case the situation is a little bit more involved than that, okay? So that's how you would approach something like that. All right, and that pretty much brings us to the end of the lesson. Let's go ahead and, per our usual practice, look at some homework problems now. All right, so in this one, we want to see what percent of the whole is shaded. So I'll help you out with this one, let you figure that one out on your own, okay? Notice that here, it's easier if we come up with the fractional part first, then we'll turn it into a percent. Like I can see that this triangle is going to be 1, 2, you have 4 of those, so this is 1/4, right? Now for this one, notice that if you take this other triangle in here and cut it in two like they did with that one, then you have 1, 2, 3, 4 parts, and 1/4 of that 1/4. So the whole triangle is 1/4, and this is 1/4 of that 1/4. So we get plus 1/4 of a fourth. So this is really 1/16, right? So we have 1/4 plus 1/16. Now if I just quickly multiply the 4 here by 4 and the numerator by 4, so I notice that the sum becomes 4/16 plus 1/16, which is 5/16, right? Now that's a fraction. I want to know what percentage is shaded, so I'm just going to multiply that by 100% to convert it to a percent. So now all we need to do is go ahead and put 5/16, and we're going to multiply by 100. So we get 31.25%. All right, so you should be able to handle this one now. Think about it, it's not that bad. Okay, on this one you have a $210 suit that's on sale for a 30% discount. What's the sale price of the suit? So here you're going to start with $210. Now, a lot of people make the mistake of just saying minus 30%. That's just 30% of what? If you don't put anything else, that's just 30% of one. Or so that's not the discount. That would not be very significant. That would be just what, 30 cents? No. So you subtract from 210 30% of the 210 itself, okay? So all we have to do now is calculate that. Now 30%, that's 0.3, right? So 210 minus 0.3 times 210 is what we need to calculate. Okay, so 210 minus 0.3 times 210. And that's where we get our final result. So $147 is the sale price. Okay, let's move on. All right, so here's a good problem. John paid $360 for a new mountain bicycle to sell in his shop. He wants to price it so that he can offer a 20% discount, but still make 10% of the price he paid for it. At what price should the price be marked? All right, so let's just figure out what is the minimum amount that he wants to make, right? So he wants to start with 360 and make 10% of that, right? So 360 plus, now we know 10%, that's just 0.1, right? And 0.1 times 360 is just 36. So he wants to get at least this much out of the bike, right? So whatever price, we don't know what price he should sell, so let's just call it X, right? We want to make sure that when that is reduced by 20%, so minus 20% of X, to be equal to this amount, right? So whatever price it is, if you mark it down 20%, you still want to make this much, right? So that's where we're going to get our results. So that's X minus, and remember 20%, that's just 0.2. 0.2x equals 396. That's 1x minus 0.2x, so that's 0.8x equals 396. So x equals 396 over 0.8. And that's how you can figure this out quickly. So let's calculate it. So 396 divided by 0.8. So 495 is what he would want to price the bike if he still wants to make $396. All right, there we go. That's that. All right, so here we have that a half cup serving of Crunchy's breakfast food has 0.4% of the minimum daily requirements of vitamin C. How many cups would you have to eat to obtain the minimum daily requirements of vitamin C? All right, so this is a very simple proportion problem. See if you can set it up before you continue. All right, so basically you have to understand that we're looking for the number of cups that would give us 100% instead of 0.4%, right, of the daily requirement. So we just set it up like this. So we say 1/2 cups is to 0.4% as how many cups is to 100%, like that. So first of all, notice this 100% is just 1, right? So we can make it simple. So we say we cross multiply, so we get 0.4% x equals 1/2, right? Now 0.4%, that's going to be divide 0.4 over 100, so move the decimal 2 places to the left. So 0.004x equals, if you want, you can write that as 0.5, 1/2. So all you got to do now is just get x, divide 0.5 by 0.004 and see what you get. All right, so 0.5 divided by 0.004, 125. So the moral of the story is that that is not the way you should be getting your vitamin C. Better go for a few oranges maybe. All right, so that's how you would handle that. All right, here's an interesting problem that could maybe look a little scary at first, but once you just write it down as an equation, it becomes really simple. You have, if 69% of the girls in a class wanted to have a prom and 39% of the boys wanted to have a prom, is it possible that 49% of all the students in the class wanted a prom? So here's what we're going to do. Let's go ahead and give these some names. Let's let B be the number of boys. Let's let G be the number of girls. And of course, the total number of students in the class will be B plus G, right? So this is what we're wondering. We want 69% of the girls, so 69 over 100 times the number of girls, plus 39% of the boys, so 39 over 100 times B. We want that to equal to 49% of the total number, which is B plus G, right? Now, notice if I just multiply both sides by 100, this is what's going to happen. don't forget on the right, on the left side, we have two terms, so the 100 is going to get distributed, right, by the distributive property. So I'm going to have 100 times the first term plus 100 times the second term, and on the other side, we multiply this side by 100 as well, right? So notice the nice thing about that is that gets rid of all the denominators of 100. So now we're just dealing with the much simpler numbers, the whole numbers. So now we have 69g plus 39b is equal to 49 times b plus g. We want to see if we can find a relationship between the number of boys and girls that would make this possible, right? So let's keep going. 69g plus 39b equals, we're going to distribute the 49. So 49b minus 49g. All right, so let's get plus 49g, sorry. Let's get all the girls on one side, the boys on the other side. So we'll accomplish that together at the same time. We'll go ahead and get the number of girls. Since the larger number for girls is on this side, let's get those on this side. So we'll subtract 49g from both sides. And now we're going to move the number of boys to the right side. So we'll subtract 39b from both sides as well. So now we're left with 20g on this side, these of course cancel out, and 10b on the other side. These of course cancel out as well. So if I divide both sides by 10, we get a nice relationship. We get b on the right side, 2g on the left side. So the only way this is going to become possible is if the number of boys is twice the number of girls. Another way we can say that is if there are twice as many boys as there are girls. All right, so a nice problem. Make sure you understand it because it's really good practice with just common sense, right? And setting up equations, etc. All right, let's look at this one more problem before we call it the day. We want to write a repeating decimal that's equivalent to each one of these numbers. So when you have a whole number like 8, of course, there is one easy way out. You can just say this is 8.0 bar, right? That is actually a correct answer, but what if we wanted to get a little bit trickier? Now, remember that we showed in the lesson, a previous lesson, that 0.9 bar is actually the same as 1, if you recall. So if I take this 8 and write it as 7 plus 1, then I can replace this 1 with 0.9 bar, right? So I can say this is equal to 7.9 bar. Now it can be shown that 7.9 bar is the same as 8, but we can see how we reasoned by a previous result. So my hint for you on these other two is that take a similar approach. Like, sorry, my touchy screen got me to another app again. So take this approach. Take 8.1 and think about it as 8 plus 0.1 and see if there's a trick you can use to write this using this fact, right? So if you just take this and divide it by 10, both sides of this by 10, right? So you have 0.9 bar equals 1. So 1/10, which is of course the same as 0.1, can be thought of as 0.9 bar divided by 10. Now 0.9 bar divided by 10 is just going to be what? Move the decimal 1 to the left, so it's just 0.09 bar. Okay, that's my hint to you. You should be able to write it now. Okay, so, and you can do similar things with that if you turn it into a decimal and then think about the first two parts that you've already done. All right, so that should do it for this video lecture. Go ahead and take care, and we'll see you for our next one, which is the last one of the term for the first part of the principles of mathematics. There's a second term of this class which perhaps we'll do together someday as well. All right, so see you next time.